Hello everybody, welcome to this demonstration on the microservice system analysis tool that we have developed at Cloud Hubs. My name is Shakthi Weerasinghe and I'll be walking you through all the features of the tool that we have developed. So basically we have two parts of this tool. So one is the Explorer and the other one is the Pipeline Creator, which is technically going to be a feature where a user can link together the different features that we have in our tool and create a custom pipeline to analyze any microservice system based on their will. So let me start with the tool Explorer. So first of all, we have the IR visualizer. So IR is basically an intermediate representation. So which is basically a format, a representation that of the microservice system, which we basically use to visualize the entire microservice system, despite it being implemented across multiple independent teams and hosted in multiple repositories. Now, first of all, if this intermediate representation has already been created, that is in a JSON format, obviously through this tool, we can get it to visualize. For example, let me take this one that I already have. So this will visualize the entire microservice system as a dependency service graph, which shows you all the dependencies between the microservices that we have in a directional graph. Now, for each of these microservices, you can click on it to find out more details about the microservice, such as what are the services that are dependent on it and what are the services that this microservice is also dependent on. But further, if you look, if you double click on that, you can also find out what are the specific dependencies, such as the controllers, the services, the entities that are also within this microservice. And you could do that for any microservice within the system as well. Now, one of the interesting features that we have here is being able to find out what are the changes that has occurred to this microservice system throughout time. Now, for that, a user can upload another IR. Now, this is the new version that we have just uploaded. Now, this may or may not include any major changes to the microservice system, but if there are, then that would be indicated as red and green. Red for any microservices and links that has been excluded from the new version, or green to indicate any dependencies or microservices that has been added into the microservice system. So a user can swap between these different versions using the timeline. So for example, in here we have two versions, so we could swap between these two. Now, if you could look here, you could see that there are a couple of microservices that has been removed from the new version, whereas there have been a couple of new microservices which has been added, and therefore some more dependencies being added into the microservice system itself. Right, now this is one of the features, and you could technically do this the same way, but now without an existing intermediate representation, by just putting in the information about the microservice system. Now, for example, what we have already visualized and seen in this tool is the train ticket system. For example, I'll take the same system here as well. Now here, I could be, I'll put in the system name, the repository URL, and I'm using the master branch, and you have to give the specific commit ID to at which point you need to analyze the microservice system. But now here you might also see that I'm using just one repository. Now the train ticket system is in just one repository, but there could be instances where you have microservices systems where you have the different microservices in multiple different repositories. Now, this tool also allows to create the intermediate representation for such multi-repo systems. What you just have to do is to add multiple repositories, and similarly to here, just put in all the details here as well. Now, if you've given all this information and just generate the graph, you would technically get the same graph as we did before, and this will facilitate all the different features that I've previously indicated here as well. There will be no change. Now, that is the visualizer. Now, one of the other tools that we have here is the formal verification. Now, formal verification is a very efficient way to assess the authorization policy consistency across the microservice system, because over time, with multiple independent teams who work independently on the different authorization policies within their own bounded context within their microservice system that they are implementing, the policy can get easily drifted away in terms of consistency. Now, in order to test that and to verify what are the inconsistencies that exist in the microservice system, what we do is essentially use the same intermediate representation, transform it into an intermediate model, and then do inferencing in order to find out what endpoints and their policies are inconsistent with the rest of the policy to leave vulnerability services for any attacker to penetrate. Now, for that, the formal verification, we would basically need the same information like the system name that we want to analyze, the repository URL, and also the commit ID, at which point we need to analyze the system. I'll get them here, and also we need to input the IR as well. Now, the point here is when it comes to security validations or the authorization policy validation, we need to look at the structure, just to look at what are the links or the dependencies that are there between the different services, the endpoints, and also to assess and we also need the code to extract what are the authorization policies that are being implemented as well. So that's the reason why we need to have this information and also the IR. Now, if you run the verification, you would see that we have two different views, the list view and the 3D graph analysis. I'll go to the 3D graph analysis in a minute. Now, what we have here is the list of list of suggestions that the SMT solver or the formal verification solver or the optimizer in it gives in order to make sure the system itself is authorization consistent. Now, if you go from, for example, if you take this endpoint, what we have here is currently this endpoint allowed any authenticated user to access the endpoint, but downstream there could be other services which this endpoint calls, which might be a little more restrictive, and therefore this suggests, so the R optimizers basically suggest that this endpoint change their authorization policy from any authenticated to just user and admin. Now, these are the three inconsistencies and the suggestions that our tool suggests for the user, and it's basically up to the developers or the practitioners, whoever is responsible for handling these authorization policies, to do the changes as it is being recommended here. Now, these suggestions can also be visualized in the 3D graph as well. Now, this would be visualized like this. Now, in here we have this particularly shown here, so that, for example, if a practitioner would or a developer would want to see what are the microservices that would be affected by this inconsistency, you can basically visualize that, okay, because of the authorization policy authorization service service that has an inconsistent policy, we see that you have the user service and a couple of other services like the cancel service might also be impacted because there is a dependency between these two services. Now, this gives a good holistic view of the system of what services could actually be affected by a simple authorization policy inconsistency, rather than just looking at these services in particular and independently. Now, this is a big advantage that we have that we offer using our tools. Now, I've covered two of the features that we have, the visualizer and the formal verification. The other one that we have is Aegis. Now, Aegis is an introspection engine. So now what this basically does is to quantify the risk that the microservice system has from latent vulnerabilities. Now, these latent vulnerabilities are technically vulnerabilities that can happen in the future, and there are no strong evidence at the moment that this will be, but based on the subtle evidences, weak evidences that exist in the system, we're basically able to probabilistically calculate the potential risk that the system has. Now, the only input to this is an IR. So let me upload this here, which will... Now this will take you through this view. So which basically contains two complementary views, to be honest. So one is the 2D risk cloud and the 3D risk cloud. So this is essentially the same thing. But the feature that we offer here is that now here we model the belief, which is the belief that the system is secure. The disbelief, the probability that the system could, or the mask that the system is potentially insecure, and this quantifies the epistemic uncertainty. Now, each of these dots are our execution paths or distribution execution paths across the microservice system. And what we have here are all the different paths that has been quantified based on their risk. Now, one of the things that I've missed mentioning before is that these risks are calculated based on multiple different sources of evidence. Now we have now the risk model, or the risk calculus that is behind this is fusing three different types of evidences at the moment: the structural evidences, the semantic evidences, and also the business context evidences as well. Now, if you click on any of these points, for example, let's take this execution path, which has the entry point administrative admin basic config. So now if you click on that, we'll see one of the things that we'll see is the entire call graph, the distributed call graph, which goes from this endpoint to this business service, which calls this endpoint, and we have these repository methods and also which accesses this particular endpoint. So you have more better view of the entire call graph. And with that, what we offer here are the different evidences with their confidence levels of what could potentially go wrong with the system in terms of security. Now, for a practitioner or a developer or a security analyst, this is going to be really easy to figure out what are the different types of risks and how to prioritize them in terms of maybe refactoring or addressing them in the system without actually having to do any guesswork. Now, that's a major advantage that we offer through Aegis. Now, these are all the different features that we offer based on the tools that we have implemented. Now, what a user can actually do using these tools are actually create something of a custom pipeline to analyze. So which means that all these different features I've introduced could be mixed and matched based on the different requirements of the practitioner, and therefore create a pipeline to test out their own microservice system. So if you launch the dashboard, now we have created this view to basically add the different features or the tools that we have. Now, for example, let's take no, not the IR. Let's say we'll generate an IR. We could create, we could use, we could generate an IR and save it in an IR card, and then potentially perform a visualization. And we can basically link them up like this. Okay, so what we do is we first generate an IR, save it here temporary, so that we can download that for visual or for any other purposes. Then we link them up with the IR visualization, so that we have a visualization as well of that IR, or basically the entire microservice system. We can do that, but we could use the IR that we generated, that is saved here, to perform formal verification as well. So we can just do it, maybe link them together as well. And once we do the formal verification, we could potentially visualize that as well, either as a list or as it is in the microservice graph. Right. Okay. So let's consider this as an example. Now, simply, what you just need to do is to give the information that we've already put before. Right, so everything is already configured. What you just need to do is to run the pipeline. So you would see the status of each process so when during the execution, and once they are ready, they will color up. So we have the IR here. Now you can download that, obviously. Yep. So, and if you want to download the formal verification results as well in a JSON format, you can do that as well. Right, now, given the analysis of the system, and now we have an intermediate representation, you could go to the visualization. Yep. So you can do that, and if you come back, potentially run the pipeline again, just quickly. Okay, now we have the formal verification results as well. You could read the verification results, which will take you to the same view that I've showed before, and also the 3D analysis as well. So which will give you the same results in a more system perspective. Okay, now these are all the different features that we have, and I believe this tool itself is a very useful tool for developers and practitioners alike, because this would allow you to do mix and match and do a lot of different analysis of maybe the different parts of the microservice system, or if you want to do a holistic analysis of the entire microservice system, you can do that too. Right, so that's all for the demonstration. Thank you very much for listening, and hope this will be useful for further analysis or further work that the different stakeholders would do in the future. Thank you so much.